If you listen to the architects of the modern tech industry, you will eventually hear a startling claim that human existence is almost certainly a digital construct. This idea has migrated from speculative science fiction into mainstream scientific discourse, gaining high-profile endorsements from leading astrophysicists and public intellectuals. The logic rests on a straightforward extrapolation. Computing power grows exponentially. Given enough time, an advanced civilization will build computers capable of running billions of simulated universes indistinguishable from reality. But this extrapolation assumes computing is essentially cost-free. It overlooks the physical and mathematical constraints governing what can actually be built in a material universe. The appeal of living in a designed, matrix-like universe is powerful. It replaces the chaos of existence with an orderly, engineered system, creating a narrative that frequently overrides rigorous skepticism. This confidence in a virtual cosmos blinds us to the actual mechanics of our universe. To see how this belief took hold, we must examine the equation that popularized it. The modern academic legitimacy of this theory stems from a 2003 paper by philosopher Nick Bostrom. He proposed a trilemma, arguing that exactly one of three things must be true. Either all civilizations go extinct before reaching a post-human stage, they lose interest in simulations, or we are currently living in one. To force the third conclusion, he applies the principle of indifference. This rule suggests that if there are trillions of simulated minds in the future, and only a few billion biological ones, any random conscious observer should assume they are part of the larger digital population. This is the formula Bostrom uses to calculate the fraction of simulated minds. It factors in the probability of a civilization reaching technological maturity, their interest in running ancestor simulations, and the total number of those simulations. Because the variable representing the number of simulations is thought to be astronomical, the biological denominator is mathematically swamped. The logic holds as a thought experiment, but it relies on a specific premise: that theoretical digital populations should be weighted equally with the biological ones we can actually observe. By treating hypothetical possibilities as confirmed data points, the formula builds a case for statistical likelihood that forces us to question our very existence, a conceptual trap that has caught many modern thinkers. Bostrom's methodology belongs to a philosophical lineage known as anthropic reasoning, which attempts to deduce the nature of the universe based on our presence as observers. Prior applications include Frank Tipler's omega point and John Leslie's doomsday argument, both of which calculate existential probabilities by estimating total population sizes across time. While software runs inside software, extending this logic to universes reveals a structural necessity. An outermost shell must house the hardware. Every computational process requires physical hardware. The chain of nested realities cannot regress infinitely. It must bottom out in a base, non-simulated reality. The simulation hypothesis effectively brackets this requirement, treating the location and material composition of the ultimate computing hardware as an irrelevant variable. Acknowledging that a base reality must exist to host the hardware anchors the hypothetical math. It changes how we calculate the probability of where we actually sit in that chain. Moving from philosophical probability to hard physics reveals the material boundaries of this theory. According to Landauer's principle, information processing is a physical action. Manipulating a bit of data requires a minimum, non-negotiable expenditure of energy. Astrophysicist F. Faza calculated the thermodynamic cost of generating a low-resolution simulation of just the Earth. To To compute the quantum states and interactions required for a convincing universe simulation, the energy demand exceeds the entire mass energy content of galaxies. A host civilization attempting this feat would require a parent universe with entirely different physical constants, like an alternate speed of light or a gravitational constant, to prevent immediate collapse from the energy drain. Because rendering a reality equal to ours demands impossible, universe-breaking resources, the Matrix-style scenario is not a technological inevitability, it is a physical impossibility. If physics restricts the number of simulations, the underlying mathematics must be updated. Researcher Shreyans Goyal provides this correction using Bayesian probability. Bayesian analysis is a statistical method that updates the probability of a hypothesis as new, certain evidence becomes available. This diagram models the correction. A 52-card deck represents all possible hypothetical worlds. Next to it, a drone hand of 13 cards represents actual existing worlds. In Bostrom's model, finding base reality is like drawing the ace of spades from the unconstrained deck, a slim 1 in 52 chance. But Bayesian logic introduces a hard constraint. Simulations require a base reality to run. Therefore, the ace of spades absolutely must exist within the actual 13-card hand. With this required constraint, the reference class shrinks. The odds shift from 1 in 52 to 1 in 13. Bostrom's initial equation inflated the denominator with trillions of hypothetical simulations that do not physically exist, diluting the mathematical weight of our biological reality. By calculating odds using the unconstrained deck instead of the restricted reality of the drawn hand, the original argument manufactured a statistical certainty that disappears under Bayesian logic. With thermodynamic boundaries restricting the creation of simulations and Bayesian logic correcting the statistical math, the core claims of the hypothesis unravel. The assumption that digital minds will automatically outnumber biological ones fails. The physical cost restricts the supply, and the updated probability eliminates the mathematical bias. This diagram visualizes the resulting collapse. The sprawling tree of infinite theoretical worlds folds inward, leaving only the required, constrained set of actual realities. Science fiction logic thrives on infinite possibilities, but rigorous epistemology demands strict constraints. To avoid an ungrounded infinite regress of assumptions, any mathematical model of our universe must anchor itself in a physical truth. The simulation hypothesis is an artifact of misapplied probability and ignored physics, not a profound insight into our cosmos. True ontological claims require accounting for the actual physical costs of information and the rigor of conditional probability. Humans are not the inevitable digital playthings or computational experiments of a post-human civilization. The universe possesses a foundation that defies computation, relying on energy demands that cannot be coded around. When bound by the hard laws of thermodynamics and the rigor of Bayesian mathematics, the most rational and scientifically accurate conclusion is that our reality is entirely authentic.